Hello, sixth graders. Welcome to this week's class notes video. You should be completing these somewhere between your classes of Thursday and Friday. Ideally, Wednesday when you don't have any classes, since the video is a little bit longer and this assignment's a little bit longer. The idea is, I think, probably easiest for you to finish these on the Wednesday. But as long as they're done by your class on Thursday, if you have me for Thursday, or Friday, if you have me for Friday, that's the due date for them. All right, so last time we finished with just continental drift. All you did was this slide. Today, not a lot either. You're not going to finish the dock still. We're going to do the next section, which is seafloor spreading. There's just 2 slides on there. No silly video like I did on the last one. So this one will be a little bit shorter. On your dock, just as a reminder, and a visual here, you did Roman numeral 1 continental drift. Okay, so this guided note stock is laid out for you guys in an outline format. So like I've mentioned before, we're going to do notes in a bunch of different ways. And so this is modeling for you how to set up an outline to keep track of your notes. So notice that the indentations are pretty much your big kind of formatting key for you to recognize where the big main ideas are and where the supporting ideas are. So last time, continental drift as Roman numeral 1, that was the big main idea. A, B, and C were supporting ideas. 1, 2, and 3 underneath C, notice how those are indented. Those are supporting details to the idea that was stated here at letter C, and then you have D. So for today, we're only doing Roman numeral 2, seafloor spreading. Okay, seafloor spreading. So you have that as your main idea, 2 supporting ideas, and then underneath that second supporting idea, there are a number of other ideas that support letter B. And that's the formatting for an outline. Okay, so it's the idea of the indentations are kind of your visual to help you organize the information and kind of like cluster it and group it into main categories and main ideas and supporting ideas and other ideas that support those ideas. All right, so let's keep going here. Seafloor spreading. Well, if you remember where we left off last week, Alfred Wegener had this great idea for continental drift, and he had the evidence, those key pieces of evidence that we talked about. But at the very end, we also mentioned how he couldn't tell how it happened, how the plates, these giant continental plates, would be moving. And so because of that, his ideas were rejected. And I think I mentioned in that video that this went on for a long, long time. That all the way into like the 1950s or the 1960s, people did not truly believe yet that there was continental drift. In fact, the people that did believe it actually had a nickname. They were called drifters. So if there were certain like scientists or college professors that supported what Alfred Wegener did and thought that he was right and that we would eventually figure out how that was happening, they had the nickname of drifters. Okay, and so it's actually a really cool story of how we kind of discovered the seafloor actually spreading apart to help prove continental drift. We're going to actually do that as another lesson because it's a cool story. It's a lady. And so back in the 1950s and 1960s, not a lot of women were in science. And we're professors at universities, and that's what this one lady was. And so we're going to learn about her and kind of that story because I think it's a pretty interesting and cool story to learn about. So anyways, the mid-ocean ridge, okay? So we have to talk about what a ridge is here in a moment. But we discovered that there was this mid-ocean ridge in the Atlantic Ocean, okay? And what we were seeing was that the actual seafloor was spreading apart and new rock was coming up on the ocean floor. Okay? If the ocean floor is creating new rock and pushing and spreading apart, well, where does the land go? It also has to move, right? If the ocean floor is moving, that means the continents would also move. So the conclusion was, well, if we have evidence of the seafloor spreading, then that would also mean that the continents are also moving. Okay? there's kind of a diagram of what the mid-ocean ridge would look like right through the middle of the Atlantic Ocean there. Here's a graphic kind of showing what is happening for seafloor spreading. This isn't the only location in the world where this happens, but it's important for us talking about the discovery of this specific ridge, which is the mid-Atlantic ridge here, because it's in the Atlantic Ocean. So this is how all seafloor spreading occurs and how ridges form, where it's underneath with continental crust. So keep in mind what you learned last time. There were two types of crust, continental and oceanic, okay? And I think I just said it wrong. It's oceanic crust here in the diagram that's showing the oceanic crust is what is separating. Okay? They're moving apart from each other, and new material fills those gaps. Okay? So it's the ocean plates, oceanic crust. All right, a mid-ocean ridge. So what is a mid-ocean ridge? Mid-ocean ridge is almost like an underground mountain, okay, like a chain of mountains. Because the seafloor spreads and new stuff comes up, it kind of starts to build on top and on top and on top and on top. And so you literally have these ridges, which are almost kind of like mountains under the water. They don't stick up above the surface of the water. So back again in the time of Alfred Wegener, if they didn't have technology to go deep down into the ocean, they would never know that these were there. And they didn't have that technology, so this information wasn't available for Alfred Wegener, so he couldn't use it to help prove his theory. As we know in life, things change, technology changes, and it was back in the 1950s. It actually started with the Navy, our Navy force, where they developed a new piece of technology called Sonar. And sonar is this idea, it's kind of like a radar, where they send these sound waves down into the water. And you guys know from studying, waves and sound in 5th grade, you guys know that sound travels in waves. And when it hits something, it can either be absorbed or it can reflect and come back, bounce back. And so that's what sonar is. It literally was this device that was sending down these sounds, and it hits something and then it bounces up. And they were able to figure out, based off how long it takes before it hits, that sound wave hits something and bounces back, how deep stuff is. And so they're mapping literally the entire ocean floor. And then they get to the middle of the ocean floor, and all of a sudden it's not nearly as deep as it is all around. And that's the discovery of the mid-ocean ridge. And so once that happens, that opens the floodgates to help give the final direct piece of evidence to support that the continents can actually move, because the ocean floor is actually spreading. All right. All right, at this point, pause if you need to, but there's not a lot for you to type. Okay, it's more listening as we go through this to some of the information that I'm explaining. Let's go to the second one here. Letter B here. So what was some of the evidence that we found when we mapped the ocean floor? Well, mapping the ocean floor is great in terms of knowing what was down there in terms of the elevation of some of those ridges, but that probably wasn't enough to support. You needed some other things. And again, you had to wait for technology to catch up. So you guys probably know that you can only go down a certain depth in the ocean before it becomes very dangerous for humans to survive because of all the pressure that's there. So again, technology comes around in the late 1960s, early 1970s, where you're able to send down these submarines that are like remote control from the surface of the water, right? So they're able to control these submarines, unmanned submarines, as they go down with cameras so they can look at stuff. Well, here's what they found. They actually saw literally eruptions of molten material coming out of those ridges and coming out of the ocean floor. Steam coming out, lava coming out and cooling as it hits the water. I mean, I don't know if you really need any other more evidence than that. They literally saw that with the cameras. I mean, that's pretty solid evidence right there, right? With these remote control submarines, they also were able to, instead of just take pictures, they grabbed some of the material. So they would actually take pieces of the ocean floor, the rock of the oceanic crust, bring it back up to the surface so that they could study it. Well, what they found out was when they studied different parts of the floor that the magnetic minerals that make up those rocks sometimes were pointing with the poles being towards the north, and some with the magnetic poles being pointed towards the south. And what that told scientists was that these rocks must not have been formed at the same time, because we had already known that the poles, the magnetic poles of our planet, sometimes switch. Okay? And we can talk more about that later. And if you're like, what? I don't understand that at all. That's okay. It's most important for you just to know that a piece of evidence of seafloor spreading was that there were the evidence of magnetic reversals in the ocean floor. And all that really is telling us is that the rock was formed at different times. It wasn't all formed at the same time. So if you have newer rock, that must mean that that rock is forming somehow, and it would be because of that molten material that would cool and harden. And then the last thing is they literally would use the methods to find the age of the rocks, and they found differences in the age of the rocks. And it wasn't just random differences in the age of the rocks. It was very patterned. And it was when you had the mid-ocean ridge and where the seafloor was actually spreading, that the rock there, the dates were really young. And as you move further away on both sides of the ridge, the further you went, the older the rocks were. So that again was proving that the ocean floor was literally spreading apart at that ridge. Okay, so there's one of the pictures of some of the molten material coming out. You might say, well, it doesn't look like a lot. You got to remember, it hits the water, it cools right away, right? So that happens quickly, so it doesn't stay molten very long. You see some of the bubbles, though, coming up, so that's indicating some of the steam and the heat that's coming up. Here's a diagram of what I was talking about in terms of the magnetic reversals in the ocean floor with the rocks. So it almost looks like strips in terms of the way that the minerals lined up based off of their magnetic principles and properties. And then here's a map. And I know it's a little bit hard for you guys to see, but it's color-coded based on red being the youngest rock and the blues and the greens and then the blues being the oldest rock. So this is the mid-Atlantic ridge right through here, what we were talking about. And so when you took rock samples close to this ridge, they were young. And then as you move away from that ridge on either side, they got a little bit older, a little bit older, a little bit older. And the ones closest to the continents were the oldest. These other lines that you would say were red lines, okay, those are other ridges, okay, that we discovered later on then. This was the big one, though. The Mid-Atlantic Ridge is what it's named. That was the big one that we discovered. Okay? All right, so seafloor spreading, in summary, was really important for us to discover because it helped prove Alfred Wegener correct in that the continents were moving, which then means that they were once joined together, and all that evidence that he had was justified through the discovery of this Mid-Atlantic Ridge. You will need to know, like I said last time, you'll need to know the evidence that Wegener had for continental drift. You will also need to know this. You will need to know these three pieces of evidence of the seafloor spreading. Okay, so make sure you kind of concentrate on those. Watch this video as many times as you want to kind of keep reviewing things since we're not doing this part in class if it helps you. And other than that, we'll talk about this stuff more and more as we keep going through the unit. All right, have a good day.